All right, hello everyone, and welcome to our math videos. Today's going to be a pretty short one, I think. We are going to be talking about component form. So we're going to figure out what component form is, although we have already talked about it. We're going to look at a couple ways to get a vector into component form, and then we're going to do a couple examples. So let's go. Okay, so just to recap, all right, component form is kind of like our standard form for vectors. All right, so it's our standard form. For vectors. All right, so before we can add, subtract, multiply, which we are going to do all of those things. And before we can do any of those kind of mathematical things with vectors, we do have to get them into their standard form, which is this component form. All right, and just to recap, component form is when you have your starting point at 0, 0, and your terminal point or your ending point at some xy. All right, so initial point, that's our starting point. All right, so this is when you have initial point at 0, 0, and terminal point, that's ending, right? Terminal means you're done. All right, terminal point at some x comma y. And then the notation, how you know something is in component form, is going to use those angled brackets. So angle bracket x comma y, that's what you would see. All right, and then visually, right, this is a vector. Starts at 0, 0, and then it can go in any direction. So if x and y are both positive, then I would be right in this first quadrant where this point right here is some x comma y. And that's a point, right? We know our arrow doesn't continue going. All right, so that is a component form vector. Now, obviously, not all vectors are going to be given to you in component form. One way that you could get your vectors presented to you is with the actual points. So it can say like initial point here, terminal point here, and they might not be at 0, 0. So you're going to need to figure out a way to take 2 points that are not at 0, 0, vector that's just like floating off and say like the second quadrant or something, and you need to move it so that it goes to 0, 0. And there's actually a really quick formula that is going to do this for us. So to transform a vector into component form. So this is kind of, I guess, when given the endpoint. So when given just the, I guess, initial and terminal point. Initial and terminal point. Z. Okay, so it's all you're going to do is you take the arrow part. So you take, it's always just going to be arrow minus tail. That is it. So whatever, it's got to tell you like your starting and your ending point. All right, arrow is your terminal point. So the arrow, right, goes at the end. All right, so the arrow, this is the like the terminal side. Terminal, this is like your terminal point. And then the tail, right, the back part, like that tail point, that's like your initial point. All right, so for instance, looking at boring letters, if we had point P is at x1 comma y1, and point Q is at x2 comma y2, then vector PQ in component form would be it's Q minus P, right? So Q would be like your arrow, P is like your starting point or like your tail, so arrow minus tail, or heads, head minus tail. I've seen that also. I like arrow because sometimes head I don't know. Sometimes I don't know. I think it can be confusing. It's arrow minus the other side, or the tail piece of it. All right, so q comes first. So it's going to be x2 minus x1, comma, y2 minus y1. Arrow minus tail. That's it. All right, and this should look familiar because we kind of basically did this in our last video. This is just this is like a piece of your distance formula. So your distance formula, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, right? So like these pieces right here, hold on, we'll do green, bam, bam, they're right here, right? Because basically what we're essentially doing is we're finding out the length like between your x's. So like, you know, x to x, how far, like what's the distance between those two? And we're basically just finding that length, and then we're drawing the exact same vector, but just we're going to start at 0, 0, and we're just going to have the same distance between our x, that like coordinates, and then we're going to do the same thing with our y coordinates, right? So you're just finding the difference between the y's and the x's, and then you're just recreating that starting at 0, 0. So that's basically the whole kind of concept. So it's like a variation. It's like, it's doing the distance formula, right? It's finding that distance or difference between the x's, the difference between the y's, and then it's just using that to start at 0, 0, and then you can just go over by the difference of whatever that amount is. So that's kind of what's happening. All right, main thing you need to remember is it's the arrow piece, or the terminal point, minus the tail, or the initial point. So terminal minus initial, or if you're thinking of it more visually, arrow minus tail. Okay, so here's an example that we're going to do really quick. All right, so we're given P and Q, and I just kind of pick these the letters don't really matter. It can be any letter. It just so like P and Q are kind of a common one that you'll see with vectors. So we have P is -3, 7, Q is 1, 4, and it's saying express P, Q in component form. So the order that they're listing our points right here is important. It's saying P is the starting point, Q is the ending point, all right, because that's the order. So if we want to find PQ, we take x of Q, which is 1, minus x of P, which is -3. And then we take, oops, stop that. We take y of Q, which is 4, minus y of P, which is 7. And then we just simplify. So 1 minus -3 is 4. 4 minus 7 is -3. All right, so PQ in component form is 4, -3. All right, so the vector has the exact same side lengths, right? Basically it has the same magnitude, right? It's going to have the same x distance and it has the same y distance. We've just now shifted it from, you know, floating somewhere in, so this one, what would it be? That's somewhere like going between like quadrant 2 and quadrant 1, to just starting at 0, 0, and then kind of going in its same direction. All right, now just be careful, because the way that I knew that P was first is because it told me express PQ in component form. I could have also have said express QP in component form, and the order matters, all right? So if they had flipped it around, that's a completely different, going to be component form vector. It's going to be pointing the opposite direction. So just be mindful of the order of the letters. So the first letter is your like tail piece, that's your initial point, and the second letter is going to be your arrow or your terminal point, and that's it. Okay, now there's a second way that you can be given information that you might have to turn into component form, and that's by being given the magnitude and the direction of a vector. So if you're given those two pieces and you actually want to put it together into a component form vector, it's actually pretty easy. And so that would be like another way that you could see a vector given to you. So let's look at that one. All right, so here's the basic concept. All right, so you're given some vector. All right, so here's our vector. All right, we'll call it u. All right, so we know the magnitude of u. All right, and we know theta. All right, so they're giving us the magnitude and they're giving us theta. What we want to do is figure out kind of like where is this point right here? Question mark. We want to know what is this in component form. So if we're starting at 0, 0, what is the kind of terminal point, kind of angled bracket that we have here? All right, what we do is we draw ourselves a triangle. So we drop down this side, draw that over. We have a nice little right triangle now. All right, this is my x-axis, this is my y-axis. So I'm just going to label my sides of my triangle, x going across the x-axis, y going across the y-axis. And if I want to find the different pieces, so let's say I want to solve for x, or I want to know what x is. So I say, okay, I'm going to like pretend that y is not there. All right, so I just want to solve for x. I'm going to use my trig functions. I have x, which is the adjacent side, the magnitude, which is going to be my hypotenuse. So I'm going to use cosine because I have adjacent and hypotenuse. So I would say the cosine of theta equals adjacent over hypotenuse. All right, I'm solving for x because remember, I know theta and I know the magnitude. What I'm trying to solve for here is x, right? Because I know the other two values. There's some numbers. I don't know exactly what they are in this one, but in the problem, I would know them. All right, so if I want to solve for x, I need to get x by itself. I'm going to do that by multiplying both sides by the magnitude. Sorry. All right, that's going to go away. So that tells me that x is going to be equal to the magnitude of my vector times the cosine of my direction angle. That's the x piece. That's how you find the x value for your component form. You just take the magnitude and you multiply it by the cosine of your direction angle. All right, same kind of thing happening here for y. So if I want to find y, all right, I'm going to pretend like the x isn't there. All right, I'm like, okay, so I know magnitude, I know the angle. How can I find y again? We're going to go to our trig functions. We have opposite and we have hypotenuse. So this is a sine problem. So we're going to set it up by going sine of theta equals opposite y over hypotenuse, which is my magnitude. And again, we know theta, we know the magnitude. The only unknown is y. So we want to get y by itself. We multiply both sides by the magnitude. Those cancel. So we're left with y is going to be equal to the magnitude times the sine of our theta, which is our direction angle. And that's what you're going to do. So that's it. So then your component form, is just angle bracket, magnitude of u, cosine theta, comma, magnitude of u, sine theta. All right, and so that's how you find component form if you're given magnitude and direction, all right, which is the second way that you're going to be given information to put into component form. So the first way is with the actual points, and you just subtract arrow minus tail. The second way is by being given magnitude and direction and having to put it together into component form. All right, so now we're going to do an example of that one just so you can see how it goes. All right, so here we go. It says find the component form of a vector with magnitude of 32 and a direction angle of 60 degrees. All right, so it doesn't matter what you call this vector. You can just give it whatever name you want. I'm going to be boring and I'm just going to call it u because it's easy. All right, so magnitude of u equals 32. my direction angle is 60 degrees. All right, cool. So to put this into component form, all I need to do is, so I have component form. Or that's so much writing. You don't need to write that. You don't need to write component form. You just need to write u. So vector u equals, all right, it's going to be the magnitude, which is 32, times the cosine of 60 degrees, comma, 32, which is the magnitude, times the sine of 60 degrees. All right, now we do want to simplify this, and 60 is a unit circle angle, so we want to actually plug in the correct unit circle values. We don't need decimals for this. We're not going to use decimals for ones like these. If your angle is something that is on the unit circle, you are going to be expected to use your unit circle values, which is why I tried to tell you guys so much you need to memorize these. But no, you didn't listen. You still haven't listened. You need to memorize your unit circle. All right, so simplifying, we have vector u equals 32. All right, the cosine of 60 is 1/2. And then we have 32. The sine of 60 is the square root of 3/2. All right, and we're just going to simplify one more time because we have even numbers. So we can divide by 2. 32 times 1/2 is going to be 16. All right, and then 32, again, divided in half is going to be 16, and then we have that √3. So that is our component form. And yes, you would be expected to give that answer. Don't be surprised. You have to use your unit circle. All right, well, that is it for today's video. I hope you guys found that super exciting and at least a little bit informative. And that is it for today. All right, bye.